Welcome to another General Interest Sharcnet webinar. The topic today is Visual Studio Code. My name is Armin Sobani and I am with Sharcnet based on University of Ontario Institute of Technology. And here you can find my email. If there is a question in your mind after this talk is over, you can contact me directly.
Okay, these are the links that during this seminar we are going to use some package management using Nix and also Git version controlling and also CMake. So there are some previous Sharcnet general interest webinars that I put the short links to the YouTube video here. You can later, if you like, you can check them. And during the webinar, we also need some CMake files to show how you can use the CMake projects in the vscode to run and debug your software. I use these files from the Sharcnet Git repository using this link. So if you want to have them, you can try this. So what's Visual Studio Code? It's a GUI or graphical user interface source code editor and also debugger. It's a free software. The source is under MIT license and binaries are freeware. It's an open source and the whole repository is on the GitHub. You can find it using this URL. It's a multi-platform and there are versions for Windows, major distributions of Linux, and also macOS. It has been being developed by Microsoft since 2015, so it's kind of a newcomer in the world of source code editors. But so far, it has so many users and positive comments. And my experience, is a really good, balance between the source code editor and IDE. So it's written in TypeScript. TypeScript is a strongly typed version of JavaScript by Microsoft. It's typical. Usually Microsoft uses their own extensions to these languages. And also CSS, and it's based on Electron. Electron is a framework for developing cross-platform applications using Node.js. Yeah. So there is another. Some of you may be familiar with Atom. Atom is another source code editor similar to Visual Studio Code since 2014. And the thing is that if you want to decide which source code editor or IDE you want to use, there are some factors. Here I put some of them that somehow is interesting for me. For source code editors, there are some pros and cons. The good thing about them is that there is no the good thing about them is that about the code editors is that they are lightweight and usually they are really fast, and they are language neutral. So it means that you can use them for any programming languages that you like. Using some, I don't know, extensions or add-ons, you can usually do that. And as it says, they are all code editors. But the disadvantage is that there is no or limited build automation. Sometimes there is it's not included, and you can't do that. You should do all of them in a terminal, or there are limited options for doing that. But another problem is that usually there is no debugger, or you should use an external debugger. The good thing about IDEs is that in addition to code editing, they usually have build automation for one or a few languages. Usually they start with one language and then they add others. So if you are lucky, the language that you want is included in the integrated development environment that you choose. But most of them, debugger is, a part of all IDs. Usually IDs, the primary reason of using IDs is the integrated debugger. So, but the disadvantage is that they are usually language oriented, so there are supporting a few languages, and if you want to add other languages, it's come as add-ons, or maybe some of the languages are not supported at all. But the most problematic part of IDs is that they are really heavyweight. For example, if you want to use IDE version of Visual Source Code, which is Visual Studio, even launching the application, for me on my computer and laptop, it takes about 30 seconds to launch. And if you work with that, there are also, most of the time, it's lagging behind. So when it comes to, selecting whether you are going to use a source code editor or an IDE for your development, these factors are important. But one good thing about the Visual Studio Code is that it's a good balance between a source code editor and IDE, in my opinion. So because it has an integrated editor, which is interactive debugger, sorry, it's more like an IDE. And the good thing is that this debugger, the whole interface is the same no matter which language you are using. So that's the primary reason that I switched to Visual Studio Code for most of my debugging, because if you develop for multi-platforms and usually you want to switch between those platforms and debug, having the same debugging interface is really a good thing. But there are other factors and for other features in Visual Studio Code, like IntelliSense, which is a kind of, it's a name that Microsoft uses for code completion. So it's not really different from other packages or source code editors, but the way it's implemented in Visual Studio Code makes it easy to extend it for other languages as part of the extension, or you can do that yourself if you feel that you like to develop something like for your language of choice. And another part is it has a built-in Git support. It uses the Git version that is installed on your system, but the code version control using Git is part of the interface of the editor. And you can extend it using the extensions. But the one thing that makes Visual Studio Code, in my opinion, better than Atom, which is more or less the same, first is the integrated debugger, and the other one is this, Atom is kind of slow. If you are using that, you can realize that even doing normal editing, it takes a while using Atom. But Visual Studio Code so far is really quick, and that's really important when you like to do codings, usually during your day work. So having a faster editor is a bonus. But a little bit about each of these features. IntelliSense, as I said, is a kind of a smart completion based on variable types, function definitions, and important modules. You can, when you start to type, it shows those suggestions, but you can also use control space after a dot or control dot to make it appear. It's more exactly the same way as Visual Studio if some of you have some experience with it. The built-in Git support allows you to review the differences between files, staging files, and make commits right from the editor. And and push and pull from any hosted SCM service that you like. And interactive debugger is, in my opinion, the best thing about the code editor, which is to make it different from other source code editors. You can debug code right from the editor, launch or attach to your running applications, and you can debug with breakpoints, call stacks, and in interactive console. The thing is that it has a generic debug user interface. It's language agnostic, and it cannot talk to real debuggers directly. It relies on an extension adapter for implementing the debugger. It has both advantages and disadvantages. The advantage is that this, no matter which language you are using and which debugger, you have the same interface. But the disadvantage is that sometimes, a debugger has more features, and those features maybe can't be accessed using the same user interface. And this interactive debugger ships with a debug extension. Visual Source Code ships with a debug extension for Node.js. So it's JavaScript is there. But if you are working with other languages, you can install other debuggers using the extensions. You can find it in Visual Studio Code Marketplace, which is already in the editor. So the last feature is the extensions. You can easily extend support the languages, programming languages, themes, debuggers, tools, and also you can support other speaking language or written languages if you want to add dictionaries or spell checkers. Extensions run in separate process and they won't slow the editor. But how you can access Visual Studio Code or run it both on your computer and on the environment? The setup overview is first install the software, then customize, and then learn to use the available features. For the installation, you can usually start with a setup page. If you go to, let me switch to, if you go to Visual Studio Code website, in the front page, first page, you can find the link for the downloading the software for different platforms. Usually it's good to download if you are installing on Windows, and also Mac. But for installation on Linux platforms, I don't recommend to use these packages downloads from here. It's much better to go to the, here in the docs. If you go, you can go to setup here, or the link that I already included in the slides. And then if you're interested to install it on a Linux, you can go here. And for different type of Linux distributions, you can find the instructions. For example, on Sharcnet, we rely on Nix Package Manager to install and run Visual Studio Code. So you can find it here. If you search for Nix here, the instruction for installing on the using the Nix Package Manager is here. But on Sharcnet is a little bit different. I'll show you how you do that in the next slide. But for other platforms, you can also find the proper instructions here. Let me back to my slides here. Under the Sharcnet systems, it's already installed on some of legacy VDI nodes. So if you connect, for example, if you check the Sharcnet legacy nodes here, for example, on VDI Fedora 20 and Fedora 23 is already installed, and you can run it using the start menu or the menu of the Linux distribution. But for others, you can use the Nix Package Manager, including Sharcnet legacy systems. So for both Sharcnet legacy systems and also Graham, you can, first things that you should do is module load Nix, and then defining this environment variable, export Nix packages allow onFree equal to 1. It's necessary because the way that the binary distribution of the Visual Studio Code is in a way that it's categorized under the unfree, but actually it's free. But in Nix, it's like that because there is some differences between how you can download the binder. So if you export this environment variable, when you then search for query for the software, it's going to show you the Visual Studio Code. So the next command, you can query the available software, and then you can use nix env-ia, nix packages vscode -with extensions to install the Visual Studio Code on both Sharcnet legacy systems and also Graham. So here, I've already done that. So if I go here and do module load Nix, if I query for installed packages, you can see that Visual Studio Code is already there. Because on Graham now we are using the Hydra server is gonna really fast. So once a user installs the VS Code and it's already compiled and built on the Hydra server, and usually the installation procedure happens really quickly. That's the only thing. If you are going to use the Visual Studio Code on Graham, but if you are going to run it under the login node, you also need a X11 forwarding enabled. So when I'm on Windows using the mobile extern, which is the software that I'm using, the X11 server and X11 forwarding is already there. So as soon as I type code here and enter, because I've already installed the Visual Studio Code, is gonna run. But you can find it here after a while. So now you can see the icon appeared here. This one is the Visual Studio Code under my Windows operating system, which is running, and this one is Visual Studio Code that is running on Graham login node. The problem with this kind of approach is that is kind of slow. So as I said, usually you want your editor of choice to be quick. So here, if I switch here and I do a new file and do, for example, some typing, you can see it's not really quick. And if you want to do so much copy and paste and those things, is not really fast. But it can do the thing. So if sometimes you want to quickly edit a code under the Graham login node and do some tests and some changes, it's a good way of running it quickly. And the good thing is that you can run several instances of the code. So if I want to open this folder using the code in another instance of the software, I can use code and dot. It means that open this folder for editing under the code. So after a moment, the cursor returns. I can run another one, and it takes for a while, and then the second instance appears here. So this one is another instance of code that is running under the Graham, but now it's opening this folder and I can see the files under it. I will return again to this and we start to explore more about the Visual Studio Code, but let me show you what's the other alternative if you want to run your Visual Studio Code on Graham. We have now our VDI nodes on Graham ready. You can access them using the address here, grad-vdi.user.sharcnet.ca. But there are two caveats here. The module system is not operational yet under the VDI. They are going to be, but not yet. And the other thing is that the project file system is not mounted yet, and also it's going to be there, soon. But if you want to use that now, you can. There are some workarounds. Here, you should first make a small shell script, which I named vdi-setup.sh, and put it in your home directory, for example, and put these 2 lines of code here. The first one, because the module is not operational there yet, if you want to run Nix and make it available, you should source this script to make it available. And the other one, this one is kind of thing if you want to work with Git under the, if the thing is that the Git requires some of the SSL or secure socket layer thing, which is maybe not there yet. And if you get some errors when you try to Git clone, this export can solve that. There is one more export which is a typo here that I should remove it, but one export is enough here. After that, you can source vdi-setup.sh, and when it's there, then you can run the Nix commands. The good thing about Nix is that once you install a package under the Graham login node or VDI, it's going to be there. So there is no need for me to do it again on Graham VDI node. So here, under the Graham login node, if I query, these are the software that I installed using Nix package manager on Graham. If I switch to VDI nodes now, if you want to connect to VDI nodes, the best thing is using a VNC client. Depending on the operating system, you may use different VNC client, but usually Tiger VNC is the thing that we use. So I have Tiger VNC installed on my laptop. Here is the address for the Graham VDI node you can use, and then by pasting here and connect, you can connect to VDI node on Graham. So you can use your username and password to gain access. If I open a terminal here, let me make it bigger. If I put Nix env here, it's not gonna find it because it's in the module system is not there, and also no module. So I have the same script in my home, which is VDI setup. If I show you is the content, if I source VDI setup sh, now Nix will be available, and if I put Nix env-q, I can see the same software that I installed and were available under the Graham login. But when you are on VDI node, because there is no other software and there is no module system yet, you need also minimal version of Git and CMake, because if the versions that are already included in CentOS 7 is not high enough for the vscode. So here, as I've mentioned, you need also, if you haven't done so, you need also this line, Nix env-I capital A, and installing Git and CMake, which installs the CMake and Git versions that are proper for using under the vscode. And after doing that, you can run the code. Because I've already done it here, Git is here, and CMake also here. So the only thing that I need to do is just running the code. The good thing about running under the using the VNC client is that now it's much faster. And as you can see, I did this untitled text under the Graham node, but because it preserved those files, when I open the code, it's already there. So, but I can also explore other folders and doing that. So that's a good feature too. Even your untitled or unsaved files can be accessed in both Graham login node and also VDI nodes. So let's have this here for a while, and we will return it again to this. After having the code up and running on Sharcnet systems, the next step is customizing. Usually customizations happens using the extensions, but some of them are already included, including themes. You can change the color themes. There are two kind of themes. One is color and the other one is file icons. You can change them. There are different key maps if you are coming from different source code editor or IDE, for example, Vim, Sublime, or Emacs, Atom. There are some already developed key maps that you can load and then start coding using the shortcut keys of your choice. And then, depending on the languages that you want to develop, you can install some extensions. For example, if you install the extension for debugging and also code completion and all the things are there. So by installing one extension, you can start coding for C++ or Python. There are some tools like different linters, and for example, for this talk, we are going to use CMake tools to build our software and debugging using the same CMake files that we have developed. And debuggers, there are some additional debuggers. For example, if you want to debug under the Chrome or PHP Xdebug or GDB, LLDB, they're going to be there. But please note, when you, for example, if you are developing using C++, the C++ extension already take care of the proper debugger. So if you are under Windows and you have Visual Studio already installed, it automatically defaults to Visual Studio debugger for the debugging. But if it is not there, it uses the GDB if it is available. And then the next thing is some fine-tuning, some tinkering with settings, which one of the most important shortcut keys here. Usually, if you want to change the settings, you can use the Control comma to get the settings. And for learning, there are some things. First, you can find and run all your commands. The second most commonly used shortcut key in source code editor, Visual Source Code, is Control-Shift-P or Command Palette. It's so common that there are two shortcut keys for that, Control-Shift-P and also F1. I usually use F1, and it shows a list of commands that is kind of smart. And there are also two links, interface overview and interactive playground, that you can use. For exploring those, let me start with here. There are some the notifications, depending, for example, it says that there is an available update here. Usually when you are under the Nix, it's not a good thing to download that because you should upgrade to the next version using the Nix package. So you can also disable this if you want. But here, the first thing is a welcome screen that appears. For customization part, you can use the two languages here. And also for installing keyboard shortcuts, depending on the thing that you like, you can use Vim, Sublime, or others here. It shows a extension window for doing that, and also color theme. You can click on this for color theme, but the best way and fastest way is using the command palette. So if you press Ctrl-Shift-P or F1, it shows the command palette here. You just put the thing that you want. For example, if I'm dealing with themes, I just put the first characters of theme here, and then all our available commands will be there. So there are two kinds of themes that I can change. First is color theme here. If I want to change the color theme, I can do it like this, and it will change. So I changed to light version here, but you can change it to one that you like. And it is also possible to change file icons. So here, for example, let me go to, these are my files under the, as you can see here, the file requester appears really quickly. But if you are using the X11 forwarding on Graham login node, it's not that fast. So here, if I go to vscode here and open this Python folder, for example, you can see the file icons here. But if you want to change that, you can put F1 here and then switch to, for example, different file icon theme. There are some already installed theme. If I change, you can see on the left that the appearance of icons are changing. But you can install additional file icons using the extension. The best extension for icons here, if you switch to extensions, is Visual Studio Code icons, which already downloaded more than 5 million times. So I've already installed this Visual Studio Code icons, this extension for my icons. So you can do that too if you like. But another thing during the learning process, the good thing is that first interface is overview. If you click on this, it shows the main areas of the code editor. Here is a command palette. The shortcut is Ctrl-Shift-P. And here are the main 5 parts that you can switch easily using these command shortcut keys or directly clicking on this. This is File Explorer. You can do all normal file management things here. There is a really quick and fast search and replace here that can search for patterns and expressions in all files in the open folder. And if you want to switch to Git source control, you go here, and debugging happens here. And the last one is for managing extensions. And there is one part here. You can see view errors and warnings here. For example, the one here shows that there is a new update for the software that if you want, you can download. And this part here, this is the status part that shows important information. And there is also an interactive playground that you can play with that if you like. There are so many things that interactively you can explore. For example, if you click on this, and you can start to change all of them together by clicking on Ctrl-Shift-L as it says. So when I do that, it's like a fast version of search and replace. And there are other features that you can find here. But let's start with our Python code here. For Python code, when you open a folder, I've already opened in the same directory, but if you want to open a folder, you start like this. Usually there is no need to make a workspace, because when you make a workspace, there are some additional files. But the good thing about the Visual source code is that you can start to use projects and debugging them without adding any additional project files. So let me start first with the CMake project, and then the next thing I cover quickly is Python. Here I put some vscode demo here. If I go here, there is one project that I have, for example, a spin tool. But let us start here. And then you can directly use the Git to clone your project. So here, if you want to do that after the editor appears, you can directly clone using F1 and then Git clone, but you need the URL for your project. So let me do it using the CMake tutorials that we had here. Let me copy this and put it here. Oh, it doesn't. Okay. Now put in here, and it asks where do you want to put this repository, and okay, I put it on the same. I've already done that, so let me do it again. You see that the last command that you are using is already there, so there is no need to typing again, but you put it here. But here I change the so would you like to open the cloned repository after doing that? Yes. So I can see all the steps here. The last step that we had is here, but for that step we need boost and also MPI version. The thing is that because there is no module system available on this machine, I mean the VDI, we should do that using the Nix package manager. So in order to do that, the best way is using Nix shell. So if I try to build this, my CMake tutorial is here, and I can go to step 10. The thing is if I start to build this using the CMake, it's not gonna work because boost is not there, and because the module system is not there, it's not gonna find it. But I can use Nix shell and then using -p as a packages to say that I need boost and, for example, open MPI to be available for this. After doing that, it makes a temporary shell that I can use it now, which has also boost and open MPI. It's not a good thing for MPI thing because usually you should use the MPI that is delivered using module system in the cluster. But for the demonstration sake, I put it here to show you how you can use that. But the open MPI, the MPI version is not going to work correctly. But you can make your software using this technique. So after doing that, I can do code dot here to start it under the same folder. So there is no need to make any project here. If you have a CMake file like this, the only extensions that you need are CMake, 3 CMake extensions that I've already installed here. One is CMake, which only shows the language support for CMake. So it has code completion and those things. But in order to build CMake projects, you need the CMake tools. And also there is another extension that you need for this thing is CMake Tools Helper. This one allows you to have code completion automatically inferred from the files that is generated by CMake tools. Because I have these tools already installed, as you can see, I can start to compile my code. So here, for example, hello CPP, if I check the status bar here, here you can see the CMake says no project, unconfigured, ready. If I click on this, here it asks which kind of build you want, debug, release, or other options. Because I'm going to later debug this using the debugger, I click on debug. So it's going to use the CMake. This CMake is the one that is reloaded using the Nix. So as you can see, it's a Nix version because it's not available under the VDI, Durham VDI node at this time. So, there is an error here. I think because I used the same, I didn't remove the previous ones. But let me see, because I've already configured it. Yes, the thing was that these are this version was already built using the previous version. So let me do things here. I had boost and also MPI. Oh, the thing is that what I missed here is, let me exit from this shell. The problem was that I didn't load the CMake 2. When I want to do this kind of thing, I should also have the CMake version that I want using the Nix. If I do this, it uses the CMake one and that's really important. Using the Nix shell, I should also mention that I want the CMake come from the Nix. It takes a moment and then it gives me the Nix shell that I need using the libraries and software that I want. Now, let me remove the previous build because it's, and go to code again. Now it's going to find because the CMake wants to find the Boost library and OpenMPI that is available under the Nix. So I should also load the Nix. Here, if I do it again, selecting the debug, and then here, clicking on all and selecting my target, it takes a while. I should wait here first till this configuration of CMake finishes. As you can see, it's going to find, this time it's found Boost and also OpenMPI from the Nix, and now it's ready. The next thing is now switching to the one that I want to build, Hello or Hello MPI. I click on Hello here, and if I want to debug my code now, I just put a breakpoint here, for example, using the F9. By the way, you can find all the shortcut keys here. If you click here, you can find the keyboard shortcuts here. And there is also some cheat sheets that I show you. But after having my breakpoint here, I can click on F5, or under the debug, I can click debug here. But I just put F5. Oh, no, sorry. This one, because I use the CMake build tools, the only way to debug is using this icon here, because it knows how to handle the CMake version. Usually you click on F5, for example, for Python, but for this CMake projects, you should use the debug icon here. So as you can see, it starts the debugger, and I can see my local variables here, and I can step one by one, or I can use the F10, because the shortcut key for this, as you can see, is F10. To go here, I can put watches and also check the variables and so on. My debugging output is also going to be here. So this way, I can debug my code using the CMake exactly the same way I do on both Linux machine and, for example, my Windows machine. The procedure, the whole procedure is exactly the same. But let me show you also how you can deal with Python code. For the Python code, it's a little bit different here. Why? Because if you're on a Graham login node, you can use module system to load your Python module and also install the Python modules that you want, for example, using pip or pip. But here on VDI node of Graham, because module system is not available, we should rely on Nix. But how we can do that, it's a little bit different here. Let me go to, I should exit this Nix shell now, because I finished with this, and all the software that I needed now returns to, and can be, freed later. But for the I put in a different directory than vscode. Okay. Here for the Python, it's a short Python plot Python. that I need Python with support with, I need a Python with NumPy and matplotlib, as you can see. If I want to load this using the Nix, the thing is different here. I should first make a Nix derivation, which you can find it here under the build Nix. I should put only two lines here. Using this pattern with import Nix packages, and if I, for example, want to use Python 2.7, I say I need Python 2.7 with packages, and with this syntax, I put all the packages that I need like this: NumPy, matplotlib, py-gdk, and etc. After doing that, I should use nix env-if. This one means install using the file. And the name of the Nix derivation here, build.nix. It's going to make a Python build that has the requested module in it. So now if I do nix env, I can see my specialized version of Python with supported modules is there. Once I have this, then I can do code dot here and start debugging my Python module, Python program or script. So in order to do that, you need first to install. I forgot to say that for C++, you need also the C++ extension that I've already installed. Is from Microsoft, in addition to CMake, those three CMake tools. For Python, you need the Python module, again from the Microsoft, this one. When it's already installed, then you can go to your file, and in debug, now you can use F5. It says that linter is not installed. If you want and like it, you can install a Python linter. Now I can do that line by line and have all the variables here. For some of the importing some of the libraries, it takes a while, but you use the same interface here. So when it returns, it turns into play button again, and you can do F10 to show that. On this setup, because the viewer is not available using the Nix, it's just nothing happens. But for example, if you are on a Windows system or on a Linux or Mac, using the same thing opens the plot2 at the, for example, here on the Windows version. If I do that, my Windows version is here. If I open folder and go to pyplot, if I do the same thing, I can go to debug and then F5. Okay, usually you need also using the Python command to select your version of Python if you didn't do that. So here, if you use the Python and then select interpreter, you can also change your interpreter. So here I have two choices: Anaconda version and Python 3.6. I switch to this one, and then, and also you can see the code completion and help is already there. So for each of these, if I put dot here, I can see all the available things. But let me do debugging here. Oh, sorry. Let me run it again. And now using F10, I can do the same thing. It takes a while. And at the end of the plot, when I do plot show, you can see the actual plot is also appears. But you may not lucky enough to have this on the VDI node yet, because the way that we used to load the modules using the Nix prevents that. But in other platforms, you can also see your plots. Okay, there are so many things, other things that we don't have much time to cover. I just wanted to show you how you can do the debugging part using one scripting language like Python and also one compiling language like C++. There are some Git features which is good also here. I don't have time to demonstrate them, but if you're doing them, be careful, especially with one of the comments that is here. I received a comment from Maxim today that seems that at least in this version it's going to be kind of problematic. But let me show you. If your software is under version control like this, you can use the Git thing here, and there will be some commands available here. This discard all changes is going to be somehow problematic in some cases, so be careful. Usually I use the Git commands directly in the terminal part here, but the things here also good, but some modules help you a lot for Git. I recommend you to install, at least if you are using Git as a version control, Git Lens and Git History are really good tools here. For example, after you installing the Git History, then you get this icon here, and by clicking this, you can get all the history of your Git repository, and you can change to them. And it's really easy to get the diff for checking the changes in your files for each version. And the other one is the Git Lens. Here, if I go to here, Git Lens show you all the tags and stashes here. So if you want to, for example, check the differences here, by clicking on this, it shows that. This one brings us to the end of this webinar. Thank you for your time.